Can I make an open source homemade MSLA printer of 2K with less than 60 bucks using these components? For example, this is a $400 MSLA printer and I want to make one for less than 60 bucks. And not just that, I also wanted to keep the same specs. And that's what we'll start in this video, believe it or not. And spoiler alert, is totally doable. So this will be fully open source. I wanted to have at least full HD resolution and the printing size close to this machine, and to only cost $60, more or less. So in that way, anyone could do it. In these last 3 weeks, I've been testing for hours and hours this very simple setup, and I think it finally works. So I think I'm 99% confident that I could make an MSLA printer for around 60 bucks. So if you also want to make such a printer, you must watch this video. That being said, let's get started. What's up, my friends? Welcome back. This is, well, a part of my previous project of an MSLA printer based on Arduino, and you probably wonder why I've put this project aside. I've got a lot of comments about that. Well, let me tell you. I'll tell you that in a moment, but you see, this PCB and all the PCBs for this project were made with PCBWay, so just a quick message from my sponsor, PCBWay. Your projects will be a lot better if you use the services from PCBWay for prototyping boards, for soldering your components with the SMD assembly service, or the Steel SMD stencil for soldering the components yourself. Or maybe you want to try their flexible PCBs, or the new services with 10% discount for CNC machining or 3D printing, together with laser metal cutter and bending, and also mold injection parts. I've just received my PCBs from PCBWay and they look amazing, especially with this new purple color that I've tried, but you can select any other color from this list. They have a very fast production time, so you can have your boards in less than 10 days, and the best of all, starting from only $5. So guys, consider using the services of PCBWay for your prototypes, and now let me tell you why I placed this project aside. Well, you see, for me, this project is done, because everything works. All is there left to do is to make the mechanical part, like building and designing a better case, adding the screws, the bearings, maybe making the bath, which is the easy part, but is very time consuming. But for me, this was the perfect project to learn everything I need to learn about MSLA printer and how to reduce the cost. And not just that, how to make it even better now and for even less money. But I've decided to put that project aside and not waste more time designing the case for a project that, if you think about it, is very limited into resolution and printing size of the screen. Because the best scenario that I found for an ESP32 with a TFT display is of 420 pixels and maybe something around 10 centimeters, which is not that big. I've even thought of using this screen because I've got this screen to work with the ESP32, but even this is bigger. It has a resolution of only 800 pixels. And as you can see, it's not that big. It's also very bad quality and very thick, very difficult to work with. And compared with what we have on the market nowadays, for example, this $400 printer has a quality of 2000 pixels or even more. We even have 4K or even 8K printers. So why waste more time designing that when we can make it even better? But how can we get better screen with ESP32 and the rest of the system? So the concept of this MSLA printer was very good. Actually, everything works. I know how to control now the light, how to get the files from the SD card and print them on the screen, how to move the motor, the sensor, the printing time, how to wait between each layer, and so on. So the concept was great. The only problem was the screen. So how can we get better screens to work with ESP32 and the rest of the system with the SD card and the pictures? Well, here's my idea. My first idea was to use a screen module like this one that I have used in previous project with a Raspberry Pi, and this has an HDMI driver. But you see, I've searched online for a lot of information how to control HDMI with an ESP32. You can do that, but it's very, very difficult. Not just that, but you also need a special driver, and the board costs like $40. And not just to mention, but this screen is not especially cheap. It costs like $60. But then I have another great idea. How can we find cheap screens? So where do we find very cheap screens? Well, smartphones, or basically any Android device. Us as a society, we are very wasteful, and any Android device that has more than 2 or 3 years, you can get from a second-hand app, you can get it for like $10 or maybe $20. Actually, I bought this for $5. This was just $10. As you can see, it works, but it has like a damage here on the screen for magnetic. I'm not sure why, but as you can see, the screen still works. If I were to use it from here to here, I could use it for my project. And it cost only $10. So can we use a smartphone screen with our project? Because smartphones are getting more than Full HD. You can easily get a smartphone with 4K. And not just that, but maybe you have one laying around. I myself have some phones upstairs that I don't use anymore for like 5 or 6 years because they are very old. But for this project, we don't need it to be very new. So yeah, with $5 or $10 or maybe even $20, you can get something like this. Actually, I found a tablet, a Samsung A7 tab, which is from 2022, I think, for only $20. I haven't received it yet, but I'm planning to use that for my project. And the screen size of that tablet is of 10 inches, which is exactly the screen size of my printer, which costs $400. So if this project works with my Android device, it should also work with the tablet, so imagine that. So now the big question is how to get the picture from an SD card, which must be controlled with an ESP32, to our smartphone, because getting picture to a smartphone is very easy. But this must be controlled with the ESP32 because the rest of the code should also control the printer, and the ESP32 should tell to the Android device what picture to print on the screen. So if this system works with my Android device, it should work with any other Android device. So if you have one laying around, you can just use that and make a very cheap resin 3D printer. Okay, so this is what I will do. Let's go step by step. We know that we can slice our 3D object into pictures with each layer. Let's say that we'll have for a 3D object like 400 layers. We copy those pictures onto an SD card and we place it inside of our SD card reader. That's the first step. So to make the test, I created these 4 pictures with the resolution of the phone that I'll be using. So when you will be slicing your files, you will change the resolution. That's easy to do. And I've placed 1, 2, 3, 4 just to see how the picture is changing. But once we have the project working, what we'll have is a bunch of pictures, like for example here, and these are each layer of my 3D files. As you can see, this is for a tower, so it starts with these layers and it goes. Let's see how many we have. As you can see, we have 996 pictures, and that's what we'll do once the system works. Okay, we have our picture on an SD card, we connect it to the ESP32 SPI port, and we start reading the files. So 1.png, 2.png, 3.png, we start reading all the files with a very simple library. So now we have the pictures. But now we don't have a TFT display anymore to send them to the TFT display. Instead, we have an Android device. So how can we send this picture to the Android device? Well, my idea goes like this. I'll create a mobile app like this one here that will connect to a website. But that website will be hosted on the ESP32 itself. So if you have the IP, you can directly connect to it. So you don't even need Wi-Fi or the internet. And this website will print a picture for each layer. So each time we change the layer, we change the picture, and that's it. Sounds very easy, but it was not that easy. Let me tell you why. Okay, so we start with the problems. For example, this is a simple code for Arduino that I write to just make a simple website. And once everything is created, it will give you the IP address. For example, this one here, you copy it, you go to a web browser, we paste it here, and as you can see, we have that picture that we have created. And that's okay, it works very good, but as you can see, we create a server, we create like a website, and this line here runs in the setup void. So this line here, server on and server on, will only run once. That means that it will create this website, which is the handle root, and this website that I've created has that same picture, and if we go here, is this one here, proj1001png, because that's the first picture that I want to print. If I want to change to the next picture, I should change the entire website, but this line only runs once when you create the server. That means that in order to refresh this website, you have to reset the ESP32. Now, and you don't want that. You could make like a dynamic website with JavaScript that receives in the handle some sort of a keyword that will refresh the new picture, and instead of 001 here in the code of the picture, it will say 002 and 003, but that is very difficult. I wasn't able to do that. So I thought on a solution. So now this is the new code that I've made, and once again I'm creating that website with this PHP or HTML code, and when I'm printing the picture, I'm calling it, let me just find it, the picture is now called actual.png, and now the website will always run this picture. We don't need to change this picture name in the code. what I will do, instead of refreshing the page with a different name for the picture, I could just refresh the picture on the SD card. So that will be made hardware instead of software. So now the website will always refresh the same name of the picture, but I will go onto the SD card and overwrite that actual .png picture. So we are printing the first picture, then I'm copying the second picture and overwrite it to the actual .png, and so on. So now each time the page will refresh, it will read the next picture without even changing the website. Does it make sense? For example, right now the actual .png is this one. If I refresh the page, it's still one. As you can see, I'm refreshing, it's still one. But now I take out the SD card, put it into my PC. And as you can see, inside of the folder current picture, the actual is the one. But let's just copy this, the second one, we copy it, we paste it here, and now we copy this name, we can delete the one, and rename this to actual. And now I insert the SD card back into the ESP32. And now if I refresh, okay, the connection got lost because I moved the wires right here. So maybe the connection between the SD card module, because this is on a breadboard, but now I should get the two numbers. So basically what I will do is everything made with the SD card module. As you can see here, as you can see in the example code, each 10 seconds or 10,000 milliseconds, I'm changing the current picture number to the next one. So 1, 2, 3, 4, in this case only 4. And I'm adding the project folder plus the number of the picture, which in this case will be 1, 2, 3, 4, and .png. And then I'm copying the file from the directory to the directory. And the from is the project folder, and the to directory is the current pic folder. So now, between each refresh, I'm just overriding that picture. Does it make sense? It's not made on the website side, it's made on the SD card side. Pretty easy, so problem solved. Okay, but now we pass to the second problem that I had. The Android device gets no information from the ESP32 when to change to the next picture. Yes, we've solved the problem that each time that we refresh the page on the Android, we get to the next picture. But how would the Android phone know when to change to the next picture? We need to communicate the ESP32 with the Android device. And for that I will use this device here, which is called an OTG adapter. It only costs like $5. And with that we can connect a USB cable between the Android device and my ESP32. So now in the ESP32 code, each time that we have changed and copied the file from one directory to the other one and we want to refresh the page, we can just print on the monitor. So for example, refresh, the Android app will detect that refresh in the serial in, and then it will refresh the website. That's the communication that I want to do between these two devices. Okay, I bet that you are now wondering why go through all the trouble to make a website, connect the Android device to the website on the ESP32, get the picture, refresh, talk with the serial monitor and tell the Android device when to refresh, if I already have an OTG connection between the ESP32 and the Android device, why not just pass that picture from the SD card through the USB cable and print it on the app? It would be a lot easier. Well, it could be done, but it got a lot more complicated because I had to convert the file to 64 base, then send it through the serial monitor, then use an extension on the app inventor, which is the program that I'm using to make the app for the Android device, and convert it back to a picture. That gave me a lot of problems. I wasn't able to make it work, so I've decided to just keep going with the option of making a website, which does work for now. So maybe in the future it's still onto the to-do list. So instead of using a website, just print directly through the USB cable the picture. But that won't be for this first prototype. Okay, so this is the app in App Inventor. This is the web browser and some labels to just print something on the screen. Anyway, now that we have that OTG extension installed, which is this one here, when we initialize the screen, we initialize the OTG connection, and then we can talk between the ESP32 and the Android phone. So when it receives this tag here, refresh, it will reload the page. So that means that in the code, for example, I'm changing here each 10 seconds, I'm changing the name of the picture to 1, 2, 3, 4, and then I print refresh. So when the app in App Inventor receives that refresh, it will refresh the page. So now we know we can talk back and forth and tell the app when we need to refresh, and also the app, it will tell with the right LN data to the ESP32 when it's ready. So as you can see, we have established communication in both ways. Okay, so the final real life example, if this works, this project could be done. So I have my Arduino code uploaded to the ESP32, which will create that website. I have 4 pictures here on the SD card from 1 to 4 just to make the test. OTG adapter, I will connect that to the phone, and right now when it's connected, it will power the ESP and this will start generating that website. Now we open the app that I've designed, I click connect, and this is the bad part. It will always ask you if you want to connect to this USB device and you have to click yes. Then we connect and there you have it. We have the first picture printed on the screen, and now each 10 seconds it should change to the next picture automatically. Obviously in the final project I will decide when to change to the next picture. There you have it, we have the 2. We just have to wait 10 more seconds, it will change to 3, and obviously in between the changes the UV light will be powered off. So we don't care that the entire screen is blank, it's white. So yeah, we have the 3. Obviously this part should be covered as well. I will have the app in the kiosk mode, so the screen will stay always on, and also the touchscreen will be disabled. So now we have the picture from the SD card printed onto the screen. Success! One bad thing about this setup is that, as you have seen, it will always ask you if you give permission to connect to the USB drive or not. And that is something that you can't override in Android, in any Android, unless you make like a special design app, which I can't. I'm using App Inventor. So for security reasons, you always have to click on the screen accept. Now, when I'll be making the printer, imagine that this screen will be below the resin vat. But I have an option for that. The app will be in kiosk mode. Basically, it will be like a separate app that will, each time that you start up your phone, it will just run that app. I've used that kiosk app for when I've made the wedding photo booth. So basically it will always stay into that app, and you can also disable the screen touchscreen and it will never go off, the screen will never turn off. That's great. But what I will do is to make the kiosk app wait for a few seconds, and the Arduino will move the printing vat in the maximum position. So you have space to just click accept, click connect, and then the printer will be ready. So yeah, that's bad, but you still have a very cheap 3D printer. It won't be the best user-friendly printer, but I think that is a solution. You make the gantry go up in the maximum position, you click connect, you click accept, and then everything is ready and you don't have to touch the screen anymore. And that you should do that each time that you reboot the printer. If you don't turn off the printer, it will never ask you again, but if you turn it off, it will ask you again. So yeah, this printer might not be the most user-friendly printer that you have, but it will be cheap. And that's my idea. I want to make it as cheap as possible so anyone could have a 3D printer, because it's amazing. For your projects, it's amazing to have one, and I know that a lot of you guys can't afford $400 for a printer like this one. And the cheapest one that I've seen on the internet is one that is called Light 3DP, something like that. It's open source as well, but it's very, very tiny. I think the Kickstarter was like $150. So I'm not sure if they will sell it separately, how much that will be. And even so, the printing size was even smaller than my first prototype, was something like this. So yeah, if you want to print like small jewelry, you could use that. Even so, the resolution I think was 320 pixels, which is not much. So yeah, if you want to go lower and lower with the price, I think this is the best idea. And not just that, but is reusing something that people are just throwing away. We are very used to just buy a new phone and throw the other way out. So yeah, in this way, you can just repurpose that screen for something great. So that's my idea for this printer. So guys, now I know that everything works. The difficult part was to get the pictures from the ESP32 to my phone. Now that I have that, I can only just start designing the enclosure and how to place the screen, and the difficult part maybe will be to just separate the screen like this one and remove the backlight, because we don't need the backlight. The white color light, we don't need it, we need UV light. So I'll just do it like this, remove the backlight from my phone as well, and then just place the phone with the screen like this and maybe the phone on the side, and let the UV light from below to just cure the resin. So that is the easy part, but it's time consuming. So the next few days or weeks I will be designing the parts. When I receive the tablet, I will design the frame where I should put the screen, and maybe in a few weeks have a finished prototype. So this video was just the introduction and just show you what I've been working on the last 3 weeks, how to get the picture from the SD card to the Android. And now that I have that, it's very easy to make the rest. So guys, stay tuned for the next video where I'll be already making the design of the printer once I receive the only $20 tablet. And I'm estimating that the total cost will be around $60. Maybe a little bit more, maybe a little bit less. But before you comment below, I know that this price depends on what you find on the market. In my case, I found a bunch of Android devices for $10 or $20, sometimes $50. But if you don't have that, this project would be a lot more expensive if you were to buy a new tablet. So yeah, don't do that. I've got this kind of comments in the project where I've made a power supply using a PC power supply that I bought for only $10. So that made the price very low, but if you were to buy a new one, the price would be a lot higher. So yeah, have in mind that this is only $60 if you find a very cheap tablet or an Android device. And the rest, I'm calculating that the lead screw and the NEMA 17 step motor is around $10 because I want them to be already merged together without the coupler. The LEDs are just $3, 20 LEDs of 3 watts, so it's more than enough. We need a MOSFET as a driver, which is a few cents. We need a driver for the NEMA 17 motor, which is like $5. And small components, the ESP32 is like $3. The PLA plastic for printing the enclosure, for me I buy it with like $15, a spool of 1 kilogram, and we don't need that much. And yeah, the dongle for the OTG connector is, I think it was $4. So if you sum that up, it doesn't even reach $60, but I'm guessing that I will use a power supply or some sort of adapter, and the price will go a little bit higher with the screws and the bearings. And we need to make the VAT, and we need the FAP film, which is only like $3 or $4. So yeah, once I have the entire list, I'll post it below and also make the project, but I think it will be like $60. So guys, I know that this project has a lot of talking and not making the actual project, but believe it or not, I've been working for 3 or 4 weeks each day into making this project. It was not an easy task to make that app inventor app and make the connection between the ESP, make the code, read the files, and even make the website. It's not something that I'm used to, so it was a lot of work, but now that I know that it works, in the next few weeks I'll make the final prototype. And this was just for you to learn how I made it and how you could also do it. So I really hope that you have learned something new from this video and maybe give you ideas for your project, and I really hope that you'll be able to make someday my project, this MSLA printer. So I hope that I'll be able to share an open source project with the code, the schematic, the 3D printed files, so anyone could make such a printer. So guys, if you want to support this kind of work, you can always check my Patreon below, as always. And if you don't want to do that, the easiest way to support my videos are to just share, comment, or even click the like button, because YouTube promotes a lot my channel if it has like engagement. So the best thing that you could do is free. Just comment below, give a like, or share it with your friends. And I really hope that you have learned something new. Stay tuned for the next update, and keep up, you guys. So guys, here I am in my workshop, another video that ended. I hope that you like it. And the most important part, I hope that you have learned something new. Anyway, I just wanted to give a thank you to all my patrons, to you guys, to the viewers who are supporting me, liking my content, sharing it, commenting below. Just check my website, check my shop, check my t-shirts. All this kind of stuff will support my channel. So thank you very much once again.